We're going over the answers. Here's the check your understanding part. They ask you, okay, so identify this rotation. So we have the shaded section was the pre-image. So this section over here is the pre-image. We can see that here's the way I would recognize it. I have a horizontal line right here. That horizontal line when it rotates this direction becomes a perfectly vertical line. I know that that horizontal line and that vertical line are going to make a 90-degree angle. That means it rotated 90 degrees. Which direction am I going? I'm going clockwise, so that means I would count it as negative 90 degrees. So over here, you can see that they rotated it. They used the capital letter R about point D because D was the only one that didn't move. So that's why they named it A prime, C prime, and B prime. A mapped here, B mapped here, C mapped there. So, and they put the negative 90 degrees because of the direction that it went. All right, so that means that any pre-image and its image are going to create a 90-degree angle. So this line and this line right here are going to make a 90-degree angle. Now they want to know angle A prime DC. They tell me right here that ADC, that ADC, so this one right here is 30 degrees. That means that this one right here, because remember that's a 90-degree angle, this one will have to be 60 degrees. So A prime DC is going to be 60 degrees. And what kind of angles does that make them? It makes them complementary. Down here, identify an example of figures that meet these sets of properties. I don't think these are exact answers. Rotational symmetry with an angle of rotational symmetry of 90. We know that you got to remember this is what you're doing. 360 divided by what will give me 90. That's what they're asking right here. And we know that it's 4. So name a four-sided figure where all the sides are the same. That's where they got the square. This one is 360 divided by what will give me 72. Well, you figure that out. That comes out to be 5. So what's a 5-sided figure called? A pentagon. Why does it have to be regular? Because all the sides need to be the same length in order for it to have rotational symmetry. Rotational symmetry with an angle of rotational symmetry of 180 degrees, and it has 2 lines of reflectional symmetry. So 180 degrees means that, and they put rhombus here. You could also put a rectangle because a rectangle has a reflectional symmetry right there, reflectional symmetry right there, and you can spin this top around to the bottom and it'll match, and then you can spin the bottom around to the top and it'll match. So that's why I said rhombus is not the only name that you could put. Rhombus will work, but so a rectangle. And then this one, they said the shape of the letter S. Again, if you spin that halfway around, it matches onto itself. So would the letter Z. If you spin that, if you move this around up here, that matches. So these are not unique answers. Down here, they want you to describe the rotation that would move the arrow pointing up with the tip at 4, 7. So over 4, up 7, and they want us to rotate it. I believe that we'd want it to go up like this. Okay, so 90 degrees because it is pointing left and they want it to point up 90 degrees. And it says clockwise about the 0.43. So the 0.43 is that one right there. So that will be your point of rotation. Leave that alone. When you rotate that, you'll be at 3 and then you'll go 4, 5, 6, 7. So that'll be pointing up here at 7. Pointing down and the tip at 0, 3. So we want the tip to be at 0, 1, 2, 3, and they want it to point down. So that means this has got to rotate up this way. So that's going to be a positive 90-degree rotation, and we're going to be rotating about that point. And then the next thing, pointing up with the tip at 3, 0. So we want the tip 1, 2, 3 to be right here, but we want it pointing up. So this is going to have to rotate like this. It's going to have to go from here to here. They say that if we go 90 degrees clockwise, notice that this point right here is now at 0, 3, and we want it to move to 3, 0. That means we're just changing places. That's going to mean that it's at the origin, and it's just going to, this right here, this one's going to rotate down here. So that would be 90 degrees, and we would end up having it like this. Okay. All right, so that's that one. Identify the direction of the arrow and the position of the tip. So they've changed what they're asking. Oops, let me see if I can erase this. They want us to rotate it 90 degrees counterclockwise about the point 43. So if we take this, and this would be perfect patty paper problem. So we take this one, we're going to rotate it counterclockwise. That means we're not going to go the same direction as the clock. So we're going to be moving it this way about that point. So that means it's going to be end up pointing down. And the tip will be, so from this point, it'll be fixed. This point's fixed, so it's not moving. So the tip's going to be somewhere right around here. Right there, I believe. Oh, no, right here. 4, -1. 180 degrees, about 2, 3. Where's the point 2, 3? 180 degrees, we're just going to spin it around. So it's going to be pointing that direction. So the tip's going to be right here and the base is going to be over here. And then 90 degrees clockwise, about 2, 0. So we're going to hold the point 2, 0 fixed, and then we're going to rotate this way. 90 degrees that way. It's going to end up pointing upward, which makes sense. It's left right now. We're going to spin it. The bottom part's going to go down, so the tip's going to be pointing up, and the tip's going to be at the 0.52. And that's best seen by using a piece of patty paper. Describe a figure that has an angle of rotation of symmetry of 10. Remember, that means 360 divided by what will give me 10? Well, that's going to be 36. So a 36-sided figure. And do you think it's possible for a figure to have an angle of rotation of 37? Well, let's see. Can you take 360 degrees and divide it by some number and get 37? If you do the math, it says no. Some whole number of rotations must bring the figure back to its original position. So the angle of rotational symmetry must be a factor of 360. 37 is not a factor. Okay, so in other words, you have to be able to rotate it an actual number of times, an integer. You have to be able to rotate it twice. You have to be able to rotate it 3 times. If you divide 36 by 37, 360 divided by 37, you get 9.7. So that means you would have to rotate it 9.7 times. You can't rotate it 9.7 times. You have to rotate it 9 times, or you have to rotate it 10 times. Okay, and then the other thing that I told you the paper, I told you that I would send you. I think I've already closed it, but I can open it. I gave you the link, or I gave you the file actually. You can, this one right here, the answers are attached. So there are the answers. You can check. So if you downloaded this, the answers are attached. Okay, if you have any questions, be sure you reach out to one of us and ask. Any of us should be able to answer your questions. Some of the others may not know about this page right here that I attached. They may not have seen it. So if you have a question about this page, you might want to ask me. All right.